All right, now part 4 only has the one question, but it's broken up into a few different parts. All right, so there's a good amount of stuff going on here, so we just got to make sure that we address everything they ask us to address. Anna plans to spend $30 on balloons and party hats for her daughter's birthday party. Including tax, balloons cost $2 each and party hats cost $1.50 each. Number of party hats Anna needs is twice as many as number of balloons. X represents the number of balloons, and like I did before, I'm going to just rewrite that. Let X equal the number of balloons and Y equal the number of party hats. Write a system of equation that can be used to represent the situation. All right, so it's got to be a system. All right, she's going to spend $30 on balloons and party hats. All right, in total. All right, so it's a total cost kind of thing again. All right, each balloon costs $2, and each party hat costs $1.50. All right, so we could say $2 times the number of balloons, each of which is $2, plus $1.50 for each party hat. She's going to spend $30 on balloons, so that's going to be and party hats. Sorry, that's going to total out to 30. All right. The number of party hats that Anna needs is twice as many as the number of balloons. So the number of hats is 2 times the number of balloons. All right, so that's my system of equations. I'm going to copy that over to the next page. Graph the system. I had every intention of copying it. I don't think I successfully copied it. Copy. Okay, it says it's copied. All right. All right, so these are the equations that we're looking to graph. We can do it by points. This kind of problem is made a whole lot easier using Desmos than it would have been on a TI. All right, so I'll type in 2x plus 1.5y is equal to 30. All right, it doesn't look like there's anything, but if you start zooming out, you start seeing where we're at. All right. For the graph itself, as long as the graph is correct on paper, then we're good. All right. So we need to label it, but just getting it on paper. So the fact that I have x-intercept and y-intercept here of 20 and 15. Maybe I want another point along the way, but that's not really necessary as long as you got a ruler, and you will have one. Just carefully plot that line with your ruler, and that's your first equation. So I'm going to label that 2x plus 1.5y is equal to 30. And then y equals 2x, that's going to have a different slope, but I can type that in also. All right. So it goes through the origin. I got this intersection point here at 612, which is right here. And then it continues on after that. Maybe I want another point. All right. If so, I can make a table of values out of it. And let's say I want to go at least as far out as I can. So the y value, the biggest it could be is 20 before it goes off the grid. So let me just keep putting values in and see when I get at least close to that. It looks like if I go to x value of 10, I get to a y value of 20. And now we have that. All right. So we're sort of restricted to the domain. They didn't really tell us, so we're restricted to the domain of the graph grid. So they didn't really tell us whether or not these graphs would continue on, but there are some values that wouldn't make sense. the y equals 2x is saying that the number of party hats I have must be twice the number of balloons. That could actually keep going. So I'll throw an arrow on that, all right? The other ones, if I go any further to the left here, I'm going to be in negative territory, which doesn't make sense. Same deal down here. If I go any further, I'm going to be in negative territory. So I don't need arrows on those, and it would not be appropriate to have arrows on those. Right? This equation is y equals, oh, I'm sorry, I mislabeled. This one is y equals 2x. All right? The coordinates of the intersection, all they're saying is state the coordinates of intersection. All right? So just state it. That's at 612. Explain what it means in the context of the problem, and that means that Anna will need, it was party hats and 6 balloons and 12 party hats. All right, and that's really all there is to it. All right, so it's kind of simple is a strong word. It's a little bit easier than you would think based off some of the more challenging questions that came before it. But there was enough going on. You had to come up with the equations. You had to graph them correctly, find the intersection, and then interpret that intersection. So I think that's where they're justifying the fact that this is a 6-point question. They always tell you in the bracket what the point value is for the question, right? So keep an eye on that. Generally, the more it's worth, the more steps you have to do.